New possibility for a unified field theory of gravitation and electricity. Albert Einstein translation by Unzicker. June 14, 1928. Some days ago I explained in a short note in this proceedings how by using an n-beam field a geometric theory can be constructed that is based on the notion of a Riemann, metric and distant parallelism. I left open the question if this theory could serve for describing physical phenomena. In the meantime, I discovered that this theory, at least in first approximation, yields the field equations of gravitation and electromagnetism in a very simple and natural manner. Thus it seems possible that this theory will substitute the theory of general relativity in its original form. The introduction of this theory has as a consequence the existence of a straight line. That means a line of which all elements are parallel to each other. Naturally, such a line is not identical with a geodesic. Furthermore, contrarily to the actual theory of relativity, the notion of relative rest of two mass points exists, parallelism of two line elements that belong to two different world lines. In order to apply the general theory in the described form to the field theory, one has to set the following conventions. 1. The dimension is 4, n equal to 4. 2. The fourth local component a -4 of a vector, is purely imaginary, and so are the components of the fourth bine of the 4-bine, and also the quantities hand h. Of course, all the coefficients of 7, become then real. Thus, we choose the square of the modulus of a time-like vector to be negative. 1. The basic field law. For the variation of the field potentials h, or h, vanishing on the boundary of a domain, the variation of the Hamiltonian integral should vanish. 81. HDR equal to 0. H equal to AA, LA, with the quantities h equal to or GA defined in the EQNs. 9. 10. Lockett. The field H should describe both the electrical and gravitational field. A pure gravitational field means that, in addition to EQN, 1. To be satisfied the quantities. Vanish, which is a covariant and rotation invariant restriction. TR. Note. Such lines are nowadays called autoparallels. Instead of this one, could define the square of the length of the local vector, a plus a plus a, and introduce Lorentz transformations instead of rotations of the local n-bine. In that case, all the h would become real, but one would lose the direct to the formulation of the general theory. Note. This refers to the session report of June 7, 1928. TR connection. There is still a certain ambiguity in interpreting, because one could characterize the gravitational field by a vanishing of, say, dH as well. 1. 2. The field law in first approximation. If the manifold is the Minkowski world of the theory of special relativity, one may choose the coordinate system in a way that h1 equal to h33 equal to 1h44 equal to j equal to 1 holds and the other h vanish. This system of values for h is a little inconvenient for calculations. Therefore, we prefer for calculations in this paragraph to assume the z coordinate to be purely imaginary then. The Minkowski world, absence of any field for a suitable choice of coordinates, can be described by HPA equal to 8 pascals. The case of infinitely weak fields can be described purposively by whereby the Ka are small values of first order, while neglecting quantities of third and higher order one has to replace La with respect to 10 and 7a, allocate it by H equal to Kaksa, Okes Okal, the Tepsilon mu Aza IZP. By performing the variation one obtains the field equations valid in first approximation.
KSO KPA Jakar plus KSB 0. This are 16 equations for the 16 quantities KAG. Our task is now to see if this system of equations contains the known laws of gravitational and the electromagnetical field. For this purpose, we introduce in 5 the gas and the O instead of the Ks. We have to define 9a3 equal to hashka equal to Ba plus Ka, 63 A plus Ka, or in first order. 9a3 dace equal to jas equal to Ka3 plus Kga from 2-1 obtains further the quantities of first order precisely. Jcap2 equal to Jkpm by exchanging A and 3 in 5 and adding the thus obtained structuring of 5, 1 gets at first. 2 Ga3x 2 Jka equal to 0. If one adds to this equation the two equations, mix cop equal to 2m1 m3 plus der mix cap minus 2 plus isa dz dz, following from 2a, one obtains according to 6.
Plus, equal to EFA dFA plus. The case of the absence of an electromagnetic field is characterized by the vanishing of O. In this case, 7 is in first order equivalent to the equation, Ra 3 to 0. Naturally, between the field equations there exist 4 identities due to the general covariance. In the first approximation treated here, this is expressed by the fact that the divergence taken with respect to the index A of the LHS of 5 vanishes identically. 2. Used as yet in the theory of general relativity, Ra's contracted Riemann tensor. With this it is proved that our new theory yields correctly the law of a pure gravitational field in first approximation. By differentiating of 2a by Ra, one gets according to 5 and contraction over a and 3 the equation mi theta epsilon alpha equal to 0, taking into account that the LHS Lass of 7 fulfills the identity. 8 Lass Li equal to 0 is from 7 follows, plus 8,263 dz dz's equal to 0 is also equal to 0 jazz. OT. The equations 8 and 9 are equivalent to Maxwell's equations for empty space. The new theory thus yields in first approximation also Maxwell's equations. According to this theory, the separation of the gravitational and electromagnetic field seems however arbitrary. Furthermore, it is clear that the EQNs 5 tell more than the EQNs 7, 8 and 9 together. After all, it is electric field does enter the equations not quadratically. Remarkable that the field. Note added in proof. One obtains very similar results by starting with the Hamilton function. HH gug AA, thus there remains a certain unsecurity regarding the choice of H3.